Welcome to McAfee Center Stage webinar series. My name is Justin Burgess and I will be your facilitator. This webinar will be recorded. If you prefer not to participate in the recorded session, please feel free to drop from the webinar now. A link to today's recorded presentation will be emailed to all participants. Our presenter today is Doug Savalski. Doug is a master technical support engineer with more than 28 years of technical and computer security experience. In his current role, he provides advice to product management on the service design architecture and operational delivery of the McAfee endpoint security products. He also provides his services for McAfee host intrusion prevention and solutions for virtual platforms. Ladies and gentlemen, here's Doug.
Thank you, Justin, for that introduction. Let's go ahead and jump on in. We got a lot of ground to cover today. Really excited to bring this webinar to everybody. So today we're going to be talking about the McAfee endpoint security adaptive threat protection. I'm going to do an overview of what adaptive threat protection is. We're going to deep dive into some of those components. And then I'll have a nice demonstration of the software, how it works, how we hope it's working and intended to work in your environments. And then we'll have some Q&A at the end. So let's go ahead and jump on in. So throughout this presentation, we're going to have some acronyms. So I just want to set the stage so that when you see some of these terms being used, everyone has an understanding of what this is. So we will refer to things sometimes as RepBO, and this is the reputation business object. We will have the Real Protect, which is our machine learning component. DAC, which is our dynamic application containment, and then obviously the scan orchestrator, which kind of takes all of those components and makes up what ATP does. With the adaptive threat protection, what we're really focused on with this technology is be able to filter and provide guidance on unknown processes and contain that process in an environment. So we'll as we go through and showing the demonstration of the software, that's the focal point of ATP. If you think of endpoint security as a whole, the on-access scanner is looking at files on the disk as they're being accessed, hence the on-access scanner. So it's dealing with all of the different types of files that might be on the disk. AP rules are handling different type of operations that happen. Exploit prevention is looking at different types of API calls, memory access, and things like that. ATP, though, is strictly looking at programs. And these are programs that are attempting to be run, or what we also refer to as PE file types, or those types of files that can be executed. This can be what we normally see, the EXEs, but it also can be DLLs. So when we're looking at the different components, ATP is part of one component in a larger ecosystem, which is referred to as ERD. Now we can run different components of the ecosystem. ENS is the base component, and then you add ATP to ENS. Then you add in the DXL client, which adds in that fabric framework. We have the GTI, which is our cloud service, where we can get reputations for these different types of processes if they're known or unknown. We have the TIE server, optional component. Some environments will have a TIE server, some won't. Then we also have the ATD server, so where we can take these unknown files and detonate them and see what they do, so we can actually learn more about what that process is trying to do. And then an additional component, which is not shown here, is actually MAR, which is an active response. So when we actually looking at this, the scan orchestrator is responsible for binding all of the scanners and taking the final action based on the reputation of the file process. In this slide, what we're seeing is that the RepBO component is the interface into the TIE server. this component will also talk to the Advanced Threat Detection, or ATD, using the TIE server. It's JTI's responsibility to execute all of the JTI rules in making the determination of the reputation. So when we're talking about the reputation, this is the reputation that's associated with all the connectivity status, and it's going to check the status, whether it's disconnected, GTI, TIE server, make sure that everything is actually available, and then either using a local cache or reaching out to the GTI cloud services and or the TIE server. And then when we get that back, that reputation will then be put into the JCM cache. And we'll talk more about how that cache works here in just a moment. Adaptive threat protection. So we are looking at file versus process reputation. And this is really what sets ATP apart from the on-access scanner. We can actually set a reputation of the file that's on disk, and then we can determine this through the event context, as when we actually scan it. So we're going to be looking at the certificate reputation, which is going to be provided from GTI or the TIE server. The rep BO will then be calculated based on the certificate chain with our best reputation that can be used to set the reputation on the files from that context, if that reputation is strong enough. The core rules in the rep BO is set from GTI. So if we, for an example, if we have a well-known process, those will come back with a very high reputation of most likely trusted, above an 85 or above. An unknown file default will be a default of a 50 reputation. So we can, these different types of reputation levels can be set via policy, so that we can then adjust how they are going to be set in the environment. So for example, a reputation of 0 is not set. If we have a known dirty file or malicious, that's going to be a reputation of 1. We'll make an immediate action on that. If we have an assumed dirty, that'll be like a reputation of 15, probably dirty, 30, unknown is 50, probably clean is 70, assumed clean is 85, known clean is 99. And then we have a known clean updater, which will be a 100, which is an internal setting. All right, so this one is actually showing you how it all comes together from the rep BO, the dynamic application containment, the Real Protect client, and then the Real Protect cloud. What the different triggers are, how that actually, and what's going to happen in each part of that chain. So when we actually are putting it all together, these are all the different components that are happening very simultaneously when we actually make an assessment of a process. So talking more about the policies, it's important to understand that the ATB doesn't manage an exclusion list. So if you have to set an exclusion, you're actually setting it on the on-access scan policy, on that file, DLL, or an executable. The better way to handle this, and this will be in part of the demo, will they be actually setting the trust level on your TIE server, so that you can actually manage the unknown file types in your environment, and or adjusting your policies so that you can allow certain actions to occur in the environment. By default, and we'll take a look at the default settings of the DAC rules, by default, they're set to report only. All the blocking actions have to be set in the environment that are appropriate for that environment. So one of the things that we get asked a lot is the performance workflows of ATP. It's the biggest impact is when you're doing excessive filtering, and you only want to do the heavy lift on the files that need to be checked. So this goes back to, we want ATP to be looking at unknown processes. That's its intended purpose. It obviously is going to be looking at all processes, but because of the local cache features of ATP, we want to make sure that well-known, trusted files are excluded, and we're not sending that type of information and waiting for a query to come back from GTI Cloud, or sending a well-known file to the TIE server. We don't need to look up outlook.exe. It's a well-known file. It's digitally signed. It's not malicious. Everyone agrees that there's no reason that ATP should be doing any type of containment on Outlook. If you're trying to prevent Outlook from running in your environment, ATP is not the tool for that. We should be using a different McAfee tool like McAfee Application Control. Adaptive threat protection is about identifying unknown processes in the environment. Specifically, we're combating malware with this tool. That's its intended purpose. Again, there's a lot of different optional components. The entire ecosystem is called EDR, and that would be ENS with ATP, the DXL framework, TIE, ATD, and then the MARC client. These are all optional components. Most customers will be using, in an enterprise environment, ENS, ATD, and usually a TIE server. They may or may not have the ATD component, and then on top of that, they may or may not have the MARC component. So if you have a TIE server, you're going to be able to make those determinations on those processes, your own workflow. You'll be able to then go in and make the determination from your security policies of what unknown processes you want to set to known trusted in your environment. Without TIE, you're going to be using the on-access scanner to set a more broad exclusion for these unknown processes. So it's two different models. Both are effective, but the one with the TIE server does allow you a greater degree of granularity when you're actually adjusting your policies in your environment. The big one, and this goes back to how long does the GTI cache keep these reputations. So the biggest example here is if you're on your local enterprise domain, and you have an unknown file that gets run. We're going to get a reputation on that file. And if it is an unknown file, the reputation would be 50. Maybe dynamically contained, depending on your policy settings. That file would then go to the TIE server. Your server administrator would, through your policies and procedures, set it to known trusted. That would then update the local cache on the system. Now, the reason this is important is when we then move the laptop from the enterprise network to, say, a salesman who's traveling, that cache is going to travel with that salesman. So if he runs that application again, that local cache will take precedent when it goes and does another check against that process. The local cache will override what is coming back from the GTI cloud, which is unknown. We'll have a local cache of known trusted, and that will be the certificate reputation that will be used. So the process reputation is the reputation of the collected code in the executing order of the process. A process will start with the lesser reputation as the main module or the parent process. It's the reputation that will be adjusted during runtime as any new libraries or content is interpreted during the running of that process. So this is a dynamic chain that gets updated. However, the thing to remember here are the time to lives. File reputation time to live is 7 days. A cert reputation time to live is 30 days. And there are some things that you can do to force a reputation change, and we'll talk about that during the demo. The other thing that ATP can do is a false positive mitigation. This is one of the stronger components of ENS 10.6.1. If we do get a false positive from the on-access scanner, before we actually convict that file, it is going to be handed over to ATP. If it is a PE file type, being a DLL or an exe, and we're going to run that through the RealProtect framework. If the GTI cloud comes back and says, no, this is a likely non-malicious file, meaning that it scores an 85 or above, ATP will override the on-access signature detection and send out a false positive mitigation event so that that file wasn't convicted. That will be treated as a threat event in EPO. The EPO administrator will be notified that there was a false positive mitigation, so that can be followed up on. But this greatly reduces the likelihood of an on-access scanner event for a false positive file deletion. This is something that can be, if you want to turn off false positive mitigation, there is a bypass option. I don't recommend it. It is a solid technology. It is fairly new though, so we do get some calls into support about, hey, I got this false positive mitigation event, and how do I handle that? So support's always here to provide guidance on these features, but it is a very strong feature that provides an extra layer of security, so you don't end up with an accidental file deletion and it ends up in quarantine. So all this comes back to how are we doing all this? So there's a lot of rules that we have created through machine intelligence, and these rules then get applied on the system. And so the rules are defined strongest to weakest. The strongest ones would be close to a definitive reputation with a very high level of confidence. A weak rule would be a new or a young rule that has limited feedback, and they do a process in a hierarchy. For instance, we will look at system metadata. Is the file a hidden file type? Are they signed by a trusted certificate? How old is the file? Was the file present prior to the installation of ATP? So all of these types of characteristics, there's about 53 different characteristics that we will look at when a PE file type is presented to ATP to make this determination through these different rule sets. And then we're constantly going through and as we get more machine learning back from the cloud services, we adjust these rules to prevent any type of false identification, or what we don't want to have is a file that's known trusted being sent back as unknown. So the attack behavior blocking rules. So this is some new rules that are specifically about suspicious process creation. So these are, as we look at the different rules, this is Rule 300, and it's going to block different types of Office applications from launching things like your scripting tools, because there's no reason that Excel or Word should be launching a Windows process like PowerShell or WScript or CScript. This is a new method that is utilized by malware writers as a path to process execution enhancement. So we'll go ahead and hijack a PowerPoint or a Word document. We'll embed some JScript code into it. When you open the file, it will reach out and try to run one of the scripting shells on the Windows operating system. So we see this actually coming in those types of vectors. And then you also have these different types of tools which we used to, we refer to as potentially unwanted programs, like admin tools. And so, we're going to be also be able to look at that and make sure that those types of what we refer to as dual use tools, because they do have value in an environment, admin tools, but you'll be able to control that to make sure that only those systems that are intended to use those tools are actually using them. So the actual rules are just set through via policy, and you can turn those on and off as you need via policy. This content, we are updating the content every month, second and fourth week. However, the Jcm content is also being updated as needed. So for instance, so far this year, we've had 5 Jcm content updates. All of the Jcm content release notes are posted publicly on the McAfee website. The URL is on the slide there for anyone who wants to take a look at this. The content, however, is delivered through our throttling mechanism, which is a new feature at McAfee. So there is a 3-day period at which the Jcm content is pushed out into the environment. For those customers who want to pull the content immediately, you can go to the Common Updater 3 site when the content is released, and you can pull it directly if you want to do testing. If you want to wait and just pick up the content as it is being updated, it's rolled out over a 72-hour period to the Common Updater and the Common Updater 2 sites. What we're looking at here is the how the rule execution is the flow of the actual rules. So the ATP debug logs are showing a rule ID and an example leading to the unknown reputation and then the candidate for further inspection by the rule protect. So what this is actually going to end up with is the cache criteria for a file process. The rules are executed through the stack in order of the strongest to weakest rule, but all the rules are actually processed, so you can actually have multiple rule triggers when we go back and look at that. Right before we get to the demo part of our presentation, we do have some landing pages, and we actually have some information online more about ATD and endpoint security. So with that being said, let's jump into something a little bit more interesting and actually take a look at the product. All right, so our demo today, we are going to be running this on Windows 10, build 1809. We are running the 10.6.1, and what I'm going to do is create an unknown file for ATD to trigger on. So let me go ahead and create my unknown file. The easiest way to do this is just take some text documents. So if we actually take a look inside one of these text documents, it's just this is just a random character string. So I'll just take some of these files. We'll add that to a self-extracting archive, which will make an unknown executable. All right, and there is my new unknown executable with a unique hash. It's never been seen before by ATD or GTI Cloud or anyone. So you can think of this as like an ICAR test sample. So the first thing we're going to try to do is just try to run it, and let's see what our program does here. All right. Well, it didn't do anything. So let's go take a look at what happened in our event log. So we got here. So we got several ATP events that came back. So we can see from our test event that the test file application was run in a container because the reputation was unknown. We have some block events here because it was we have some different rules because this particular application was trying to modify user data folders, in this case the desktop. We got 3 events hits on that because of the different things it was trying to do. So let's go take a look over here on our EPO server. And we take a look at our tie reputations and see what's actually happening. Okay, so this is the test file that came over. So now we are looking at this from the viewpoint of the security administrator. So we know based on the information that ATP was able to gain about this file that this was a 7-zip and it was unknown. We'd probably have some additional information from the help desk ticket that came in. So we know what that is. So we're going to go ahead and update that composite reputation of unknown, and we will go ahead and file that as a known trusted. Now I will override that. Now our test file is here, known trusted. I should be able to run it again. Now we're able to get the result that we wanted. The executable ran, and we were able to actually extract the files. So the demonstration here is actually showing a typical workflow of an unknown file using dynamic application containment. When the unknown file was originally executed, we got multiple threat detections showing us the different type of event that occurred. And then we were able to mitigate that event using a tie server by setting the policy from unknown to a trusted application. That is the end of my demo. I'll go ahead and Justin, I'll let you take over from here.
All right, sounds good. Thanks, Doug. All right, well, thank you everyone so much for joining today's webinar.